Hey, good morning, everybody. This is Mr. Ainsworth, and we are going to get into section 3 here, dealing with irrational numbers here in MRWC. And we're going to get into a couple topics about the distance formula and its related cousin, which is called the Pythagorean Theorem, which dates back to the Pythagoras days, back in the Greek times, believe it or not, about 2,000 years before Christ, whenever Pythagoras was alive. So this stuff's pretty old. All right, we're going to be using the Pythagorean theorem that you learned a long time ago. Okay, you probably studied it in middle school because it is probably the most famous theorem that dates back to the Greek times that is used in high school. All right, so let's get right into it here. In order to understand the distance formula, you need to know the Pythagorean theorem. All right, so let's start with that. So get out your red pen and let's do this here. All right, so using the Pythagorean theorem. Pythagorean, all right, theorem. Now, Pythagorean theorem deals with right triangles only. So we're going to be drawing right triangles. These are right triangles only. Little note, okay? So let's see. Let me just make a note of that. Okay, so right triangles only. And I'm talking about triangles that look like this. Let's just draw one right here. You guys, a triangle with a right angle in it. It has two legs, and let's call them A and B. This is probably how you guys were taught back in middle school. All right, and the longest side, called the hypotenuse, is C. All right, and so most commonly known or remembered as A squared plus B squared is equal to C squared. All right, where A and B are called the legs. Okay, so this is a leg and this is a leg. All right, and the longest side right here, see? The longest side is called the hypotenuse. Hypotenuse. Okay, so that's typically how people remember it. But in our diagrams here today and throughout the entire lesson, there are no variables that are used or that are called A, B, and C. So it's a better way to remember it is this way right here. So what you're going to do is you're going to take the leg squared plus the other leg squared. Those are the two shorter sides next to the right angle right here, that 90-degree angle. And C is the hypotenuse, so then it's going to be set equal to hypotenuse squared. Okay, that's a better way to remember it because usually you don't see A, B, and C in the diagram. You're not going to. So this right here is the better way. All right, so now let's do this. Okay, so let's go ahead and draw a picture here. Let's go to the graph and let's label a couple points. We're going to call them A and B. And before we state the distance formula, we need to understand it, and it's all based upon the Pythagorean theorem. So let's pick a few points here. Let's go left 3 up 2. Okay, right here. I'm just picking a couple points at random. I'm going to call this point A, and that's left 3 units up 2 units right here. That's 2 right here. So that's going to be negative 3, 2. So label your coordinates right there. Left 3 up 2, negative 3, 2. And then let's go right 2 up 5, and you're way up here. All right, and you're at point B. And so if you go right 2 units up 5 units, you're at 2, 5. All right, so what we're going to do is we're going to draw, or we want to find the distance between A and B. That's the whole goal. All right, and like I said, finding the distance can be found by using the famous Pythagorean theorem, which is probably more well understood than the distance formula because it's so abstract. All right, so what we're going to do is we're going to draw a picture here. Okay, draw the distance from A to B. So get out your straight edge there. Now we call that distance AB. I'm just using a bunch of geometry symbols here. So the distance between the 2 points is denoted by the points. So we call that distance AB. And again, you don't need the distance formula to find any distance. All right, you can only you could always use the Pythagorean theorem. So what people usually do, those people that have a hard time with the distance formula, is simply draw a right triangle. Because most students, by the time they get into 7th, 8th grade, know the Pythagorean theorem and can square a couple numbers, especially if they're whole numbers. All right, so to find the distance of A to B, all right, what we're going to do is we're just going to count the length of the sides. Okay, so 1, 2, 3, 4, 5. That's 5 units here. Okay, so you count your units. Okay, the distance here. we'll call this point C just for funsies right here. So the distance from A to C is 5 units. The distance from C to B, the vertical distance right here, is 1, 2, 3 units. All right, so if we were going to find the distance from A to B, we kick in the Pythagorean theorem. So here we go, starting with the legs. So again, this is called a leg, and this is called a leg. The two shorter sides are called legs, and the hypotenuse right here, which happens to be 5 units. Happens to be AB right here, is the longest side. Okay, so here we go. So leg squared. So 5 squared plus 3 squared is equal to hypotenuse squared, which we call AB. All right. That stands for the distance from A to B. Notice there's no C in the diagram. Okay, well, there's a point C, but that's C in the Pythagorean theorem represents a length. So again, that's why I don't suggest remembering it as A squared plus B squared equals C squared, because if you notice on the triangle here that's given, all right, there's no C on the triangle, with the exception of the point. But I'm talking about distance here. All right, well, so obviously 5 squared is 25, because 5 times 5 is 25. 3 times 3 is 9, and that's equal to AB squared. Okay, you add, you get 34. And to solve for AB, you're going to square root both sides. Why? Because that is the inverse of squaring. Okay, so you square root both sides. The square root of AB squared gives you AB, and voila, you get the square root of 34 is equal to AB. So that's the distance. Okay. Now 34, the factors of 34 are 2 and 17. So 34 is equal to 2 times 17, and these are both prime numbers. Okay, 2 and 17 are both prime numbers, so you can't simplify the square root of 34. Now, I started off with the Pythagorean theorem because out comes the distance formula. So in general, this is what we have. Okay, now to get the vertical distance here, well, actually, let me start off with the horizontal distance. So to get the horizontal distance in general, okay, using the coordinates of the points right here, you have to use the x coordinates. Let's highlight them for a second. So the distance from -3 on the number line to the distance to 2 in the number line, so this distance right here, all right, we know it's 5 because we counted, okay, but the question is like, how do you use the coordinates of the points A and B, the ones in blue here, to get the length of 5? Do you add -3 and 2? Do you subtract, and what order if you do? So -3 plus 2 is obviously -1, and that can't be the way to get the distance there. But the way to get the distance between any 2 points is by subtracting. Okay, subtracting. That's how you get any horizontal distance. And you take the point on the right, subtract the point on the left. So 2 minus -3 obviously is 5, okay, because there's a double negative right there. So in general, if we call these points, let's see, point A is x1 comma y1, so x1 comma y1. Those are our general coordinates for these points. And we call point B in general, we call it x sub 2 comma y sub 2. Notice that I'm using subscripts now, okay? These subscripts just denote the point, okay? If you see a subscript of 2, it means the second point. X sub 1 means that it's the first point. Okay, so all you do is take the second coordinate, subtract the first coordinate. So this distance can be found by taking x2 minus x1. And now let's talk about the y values, or the vertical distance. So how do you get 3 using the coordinates? So let's highlight the y coordinates. So how do you get 3 using the y coordinates of 2 and 5? So obviously we start off at, if you get a point C right here, notice that it's 2 high, and then point B is 5 high. So using these y coordinates here, 5 and 2, how do you get 3? Well, do you take 2 minus 5 or 5 minus 2? And so it's obvious, hopefully, that you take the big minus small, so 5 minus 2. Because if you take 2 minus 5, you get -3, and distance can't be negative. So in general, to get this y, this vertical distance here, you take the second y coordinate, the one above, okay, subtract the first y coordinate, the one below. So in general, y2 minus y1. So applying the Pythagorean theorem here on the general coordinates here, so applying the Pythagorean theorem, you take, let me start in red here. You take this quantity right here, x2 minus x1, and you square it, okay, just like you did before with the distance. And then you take that vertical distance, which in general is y2 minus y1, so y2 minus y1, and then you square it, and that's going to be equal to the hypotenuse squared, which is still AB. This is in general. I'm developing the distance formula now. Okay, and then you square root both sides. And you get this fancy formula here. You get the square root of x2 minus x1 plus y2 minus y1 squared is equal to AB. And this, my friends, is the famous distance formula. Okay? So let's just make a little note of that. This is your famous distance formula to find the distance between any 2 points without drawing the right triangle. So let's highlight this baby right here. Now you saw this in Algebra 1, or you should have, and you should have seen it in geometry. So hopefully this sounds familiar, both the Pythagorean theorem and this distance formula here. So we're going to apply it here. And we're going to find the distance between t and j. Okay. So what I'm going to do, actually let me expand this a little bit, is I'm going to just organize my points. We're going to line the points up vertically so you can see the distance, because the most common mistake people make is they mix up the x and y coordinates. So what we're going to do is we're going to line up the points vertically. So get out your red pen and line, write that down. So line up points vertically so you can organize your order pairs. So t, okay, is 3 comma negative 5, and then j, okay, that's negative 2 comma 4, and we want to find the distance. Okay, this is a distance problem between t and j. All right, and so we want to take the second x coordinate minus the first x coordinate. So you have to understand that every order pair is in the form of x comma y. So 3 is your first x coordinate, and negative 2 is your second x coordinate. So let's subtract up. All right, and here we go. Let's set it up. So the distance now is not a to b, right? Because we have new points. So we call out the distance tj. That's going to be equal to the square root of negative 2 minus 3. Again, you start with the x coordinates. They come first. Okay, so you take negative 2 minus 3 and then you square it, plus the difference of the y coordinate, starting with the second one. So you subtract up 4 minus a negative 5. So 4 minus a negative 5. Not 4 minus 5, 4 minus a negative 5. The most common mistake in the distance formula work is that people do not pay attention to the negative and positive signs, okay? So make sure you pay attention to that. So the square root of, what is this? Let's see, negative 2 minus 3 is negative 5. 4 minus a negative 5 is 9. There's a double negative there. Okay, and you square first and then add. Okay, so square first, then add. Make sure you follow the order of operations. Okay, so starting inside the root, so you get 25 here, you get 9 squared, which is 81, and you add the 2, you get 106. So you get the square root of 106. Now the question is can you simplify that? Because it says simplify the root if possible. So let's go over here and look at that. So you have to take 106 and you got to factor it. So it's even, so divided by 2, you get 53. And guess what? 53 is prime, so you can only divide it by itself. Okay, so the factors are both prime. which means you cannot simplify it. All right, and so we're done. So we get this distance here, which is the square root of 106, which is a little over 10 units if you graphed it. All right, and that's what we want to get used to here, guys. So let's try it again. So let's take points A, so it's -2 comma -4, and W, which is 3 comma -1. And then let's subtract up, and let's figure this out. Always subtract up, because you have to take the second x-coordinate, subtract the first. And if you line them up vertically, you won't make any mistakes because you just subtract straight up. Putting that point in points in red for you guys, because you have to make sure you follow the formula specifically here. So here we go. 3 minus a -2, so the square root of 3 minus a -2 squared, plus, be careful here, a -1, all right, -1 minus a -4. And again, the most common mistake people make are the negative and positive signs, so slow down and pay attention. So 3 minus -2 is 5, and then you got to square it. -1 minus -4 is -1 plus 4, which happens to be 3. And then you got to square that. So you got to square first, then add. So you get 25 plus 9, which is 34. So you get the square root of 34. And as I said before, above there, the factors of 34 are 2 and 17, and they're both prime. And because of that, you cannot simplify any further. So there you go. There's the distance formula and the Pythagorean theorem used together. Okay. Now let's talk about simplifying a root, because when you use the Pythagorean theorem or the distance formula, it doesn't matter. You have to simplify radicals. So let's make sure that you guys know how to do that too as well. Okay. And there is something in algebra that we need to know. So going back, and this is the key concept right here, is that the square root of a times b is the square root of a times the square root of b. So notice that we have a product here. Okay, so the square root of a times b, not a plus b, is the square root of the first factor times the square root of second factor. So you just got to square root both factors. Square root both, underline that word, factors. Okay? And simplify the results. That's the key. That's how you handle it. This is a property in Algebra 1. So the factors of 8 are 4 and 2. So you take the square root of 4 times the square root of 2. Okay? Notice that I square root both factors. The most common mistake here that I see is that people only square root one of them. Okay? So you got to square root both factors. Okay? And then you simplify. The square root of 4 is 2, and then you get times root 2, commonly known as 2 root 2. So 2 root 2, 2 rad 2, 2 times the square root of 2, okay? Okay, so it's a two-step process right here. So step 1 right here is you square root both factors. Square root both factors is step 1. Step 2, right here, you simplify the result. Obviously, the square root of 4 is 2. So that's the simplifying. So step 2 is simplifying. It's a simple two-step process. Step 1, square root. Step 2, simplify. That's it. So all you have to do is visualize the factors of a number. Okay, now 28. So 28, if you don't know the factors of 28, well, then you start figuring it out. So 28 divided by 2 is 14, divided by 2 is 7, divided by 7 is 1. So obviously 2 times 2 is 4, so the factors of 4 and 7. So the square root of 4 times the square root of 7 gives you 2 root 7. All right, a 2 rad 7. Now 27 is not even, so you divide it by 3, you get 9. Divided by 3, you get 3. Divided by 3, you get 1. So you get a square here, and the factors are 3 and 9. So this gives you the square root of 9 times the square root of 3, which is commonly known as 3 root 3. So you square root both factors, and then you simplify. Now, when the numbers get bigger, you might want to factor. Okay, so and you look for squares. So 84 divided by 2 is 42, divided by 2 is 21, divided by 3, because it's odd, it's divisible by 3, not 2, is 7, divided by 7 is 1. So I see a square here of 4. 3 times 7 is 21, so there are the factors. So 4 times 21 is 84. So you square root of 4 times the square root of 21 gives you 2 rad 21. So you square root both factors and you simplify every single time. And we'll get some practice on that because this stuff comes up. So you got to learn how to simplify in the first activity, 3b1. And if you don't know how to simplify a root, then you're not going to be successful. So this is, I'm going over all the prerequisite skills to be successful. All right, now let's play with the Pythagorean Theorem again. So we're going to play with the Pythagorean Theorem, and I'm going to give you the legs, and you're going to be finding the hypotenuse. Okay, so I said find the missing side lengths, but I want you to find the hypotenuse. Okay, so given the legs. So I'm going to give you the length of the legs. These are all right triangles, so put the right angles in. Okay, couldn't do that on the computer. Okay, so here we go. So given the legs, so let's start off with the leg lengths of 1. So given the legs of 1, what is the hypotenuse? All right, so let's figure that out. So let's find C. Each time. So remember, the Pythagorean theorem is leg squared plus leg squared is equal to hypotenuse squared. So you always start off with the legs. So here we go. So finding the hypotenuse right here. Okay, we're going to be taking 1 squared plus 1 squared is equal to c squared, which is 1 plus 1, which is equal to c squared here. 1 squared is usually 1. So since 2 is equal to c squared, when you square root, both sides, you get the square root of 2 is equal to c. Okay, so the three sides are 1, 1, and root 2. Those are the sides of the right triangle here. So in this case, we have a right triangle with an isosceles right triangle with the side lengths of 1 and the hypotenuse of root 2. All right, so now let's build on to that. Let's suppose that I give you, I don't know why it's doing that, the side lengths 1 and root 2. Root 2 is larger than 1. Root 2 is about 1.4. So put that on the longer side. All right, so here we go. So let's take 1 squared plus root 2. Well, in fact, instead of calling this c, let's call it d. Okay, so root 2 squared is equal to d squared. So you get 1 plus 2 is equal to, the square root of root 2 is just 2, is equal to d squared, and that gives you 3 is equal to d squared, and after you square root, all right, you get the square root of 3 equals d. So the side lengths, the sides, are 1 root 2, and in this case it's root 3. So 1 root 2 and root 3. 1 squared plus root 2 squared gives you the square of root 3, or the square of root 3. Yeah, I said that right. Okay, now let's build on to it here. Let's suppose that on the next one here, I give this to be 1. All the vertical lengths on the vertical sides are all the same distance. They're all 1. And let me put root 3 here. You know, what is the hypotenuse? Okay, let's call this one E. So 1 squared plus the square root of 3 squared is equal to E squared. Again, we're trying to find the hypotenuse. Okay, so you get 1 plus root 3 squared is just 3 is equal to E squared. That'll give you 4 is equal to E squared, and obviously E's got to be 2 because 2 squared is 4. All right, so you square root both sides, and you get 2 is equal to E. So in this case, I get side lengths of 1 and then root 3 and then 2. Okay, 2. You can call it root 4 if you want. So this is equal to root 4, which is also equal to 2. Okay. Now, the last one here, let's call this vertical side length 1, but this time I'm going to give this side length of 4, root 4, excuse me, which is the same as 2. All right, so what do we have? So 1 squared plus 2 squared is equal to, let's call this f, okay? F squared. So you get 1 plus 4 is equal to f squared. That'll give you 5 is equal to f squared. And then you square root both sides, you get root 5 is equal to f, okay? So this is equal to square root of 5. So we're just playing with the Pythagorean theorem here, trying to get the possible side lengths or the possible hypotenuse, okay, given the legs. Okay, remember the shorter sides are called legs. So these are legs. So that's a leg, 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 and again, the sides adjacent to the right angle are called legs. So given the two legs, find the hypotenuse. All right. And that's all there is to it. Now, in respect to this first part of the lesson here, the distance formed in the Pythagorean theorem, your homework is on page 6. So let's make a little note of that right here. Okay, they're all labeled in the lower right-hand corner. Okay? All right. And that's all there is to it. There's going to be more. Oh, good morning there. That's my dog. All right, there's more to it here, and we will get into more lessons in the future. And I'll see you in the next lesson, all right? This is Mr. Aynes2020. I'm out of here, and I'll see you next lesson. Bye-bye.